Aloha, we are here at the rooftop of SALT at Our Kakaʻako, where we are getting ready for a fun evening of stargazing. We've got plenty of telescopes, space for people to have picnics. You can come on out till 9 p.m. tonight, and there are hands-on activities down in the barn area. So come enjoy an evening of food, drink, and science fun. Aloha and welcome to October 1st on a stargazing at SALT at Our Kakaʻako. The sky is still bright, but we've got telescopes set up and looking at the moon right here on the rooftop of SALT. And we've got all kinds of hands-on activities in the barn downstairs. So come and join us. There's telescopes of all shapes and sizes and professional and amateur astronomers sharing the view. We'll be looking at Jupiter and other things later.
apologize for looking now. But hello, Makapo. My name is Senpai King. I'm the executive director of ʻOhana and one of its founding members. I just wanted to say mahalo to everybody here for coming out and to share a little bit about our group. As Leilani mentioned, ʻOhana is a Native Hawaiian organization, 501c3 nonprofit dedicated to promoting and supporting astronomy and space sciences in Hawaii and beyond. And I want to say specifically that we're on a mission to cultivate, nurture, and support the advancement of youths, specifically our keiki, in our communities who have a desire to connect or who already have a connection with the science and study of the stars above. Now, I want to bring into this space, if I may, some very important people who are the other founding members of ʻOhana Kilohoku. Mailani Neal, one of our early astrophysicists, Native Hawaiian astrophysicists, and most importantly, Kalepa Babayan. I don't know how many people here know Kalepa Babayan, but he was a Hokulea navigator and captain, and he was the heart and soul of ʻOhana Kilohoku. He was what brought the strength and credibility to our organization. He spoke a level of fluently and knew how to navigate the seas. And unfortunately, Kalepa passed away shortly after creating this group. And that's why I want to mention him here today and say that this is really an honor of him and in his vision of celebrating our traditional cultural heritage of celestial navigation and natural observation and perpetuating that culture through contributions to science and to our community. So I want to say mahalo nui loa also to Our Kakaʻako and to SALT and to Messier Schools for hosting us here today. I want you all to know that ʻOhana Kilohoku is promoting this ʻOhana Stargazing event in order to help to bring in people like Messier Schools that want to share a telescope and host the telescope. So if you're interested in putting on your own star parties, please come find me or find Leilani and get in touch with us, and we can start a program to help you guys get integrated and help get you a telescope and teach you how to do star shows. And in the end, what ʻOhana Stargazing really is about the ʻOhana we have here, getting everybody together, and also sharing everybody's relationship with the sky, showing that it's all equal. We all have knowledge and ike to share with each other. So mahalo nui loa, please enjoy, and come downstairs to the bar too. Don't forget we're down there also. Aloha.
Aloha. Aloha Kako, we are live streaming from the rooftop of the parking deck at SALT at Our Kakaʻako. Right now, we are looking at the moon because the sky is still bright. If you have any questions about astronomy or what we're looking at, please go ahead and ask, and we're here live answering your questions. You can go ahead and put your questions in the comments of our live stream at youtube.com/UHIFA. We're using a telescope called an EV scope, which is an all-electronic telescope with an electronic detector like the ones in your iPhone or your Android phone, but it can take longer exposures, so we can look at bright, dark objects or fainter objects once the sky gets dark. Right now, if you're looking at the moon, then on the right side, you'll see a very round circular feature that looks kind of like an eyeball. That is Mare Crisium. And the sort of, I would say, Australia-shaped feature is called Mare Tranquillitatis, or you may have heard of the Sea of Tranquility, which is where the Apollo missions landed. If you're out watching the sunset right now, it looks like conditions are good for a green flash. So step away from your screens and go ahead and look outside. Since the sky is still quite bright, we'll be on the moon for a little while, and when it gets dark enough, we'll head over to Saturn. But before then, we'll go and give you a little tour of some of the activities downstairs in a few minutes. Aloha. We are down here at the barn at Salt at Our Kakaʻako, where we have all kinds of activities to share with you. We have a Lego station from the Hawaii Lego users group, showing off some original creations from our members, and an area where we've got a lot of excited builders building. On the other side here, we've got the University of Hawaii's Institute for Astronomy. We've got some telescopes upstairs, but they've also got a scale model of the solar system where this yellow ball is the sun. And along the way, you can walk out to the various planets and see how tiny they are. That tiny black dot right there is Mercury on top of the golf tee. And both the distances between the planets and their relative sizes are all scaled accurately. Our colleagues from the Institute for Astronomy are also doing demos of how we learn about the universe with light using spectroscopy, breaking the light into rainbows. So we're looking at what different gases look like through diffraction gratings, which turn the light into rainbows. We've got activities from Kamehameha School, the owners of the land here at SALT, where they're doing star compass activities. And in fact, there's a beautiful star compass that was painted on the ground here at last May's event. Next door to that, you can learn about Polynesian navigation and voyaging across the islands using virtual reality goggles. So there you can see one of our future navigators trying it out, and you can see what they're seeing on this big screen. And finally, at our last station, we have what's called the gravity well, where these marbles in this curved surface make orbits as you drop them in, just like they do around any massive object, like a black hole, or the sun, or the earth. And you can change how curved the space is by changing the mass, and change the orbits by moving the balls at different directions and different speeds. And you can learn about traditional Hawaiian relationships with stars and astronomy with our friends from ʻOhana, who are helping sponsor this event. So come on down and check out all these activities and enjoy a fine dinner, some drinks, and have a fun evening out with everyone. Thanks for joining us.
later in the night, maybe about 6:45, Saturn is gonna start to come out, and that's the coolest thing you've ever seen in a telescope. So make sure you see that. But we just want to share something about the moon, the planets. At 7 o'clock, we're going to have Lonnie Murphy talk about navigating. She's one of the hopefully the navigators. So, for now, the telescopes are all looking at the moon until it gets dark enough to see the planets, of course. Some interesting facts about the moon. It's about 250,000 miles away. It takes an astronaut about 3 days in a tin can to get all the way events. Unfortunately, they're not doing any public events right now, but that's how I started. And it just started off out of curiosity to see really cool things to the telescope. I gotta know more. Yeah, so that's why we want to bring everybody here is to look up, ask questions, be curious, look for the answers, and I got a narrower eye. We gotta do something fun. Or the Barlow decided to go on a limb and just start a stargazing business. You'd be surprised what you can see in the city. I grew up in Honolulu, and so I know what's possible to see in a light pollution area. You just gotta look up the moon, the planets you can see in the middle of New York City. And so that's why we timed this show, this event with the moon and the planets.
Sorry, my phone's broken, so I don't have
Your phone?
No, I don't have a phone.
Jupiter's down there.
All right, guys, so that's my time. If you guys want pictures of the moon, come to my station. We can take pictures in 2 seconds. It's very easy now. Something to take home. And all the other stars, it's going to be very difficult to take pictures, but the moon, super easy. And so find me next to the telescope, bring your camera, and we'll take pictures for you. Thank you.
All right, we're gonna head off the moon and take a few minutes to go make our way over to Saturn, which we can see with our naked eye. It's not in the sky. We just need to get our telescope aligned. And so we're gonna go back to our welcome screen here for a few minutes, and then we should come back with the live view of Saturn from the rooftop of Salt at Our Kakaʻako for ʻOhana stargazing. We're actually streaming now, but we're in the process of slewing over to Saturn. So we should have Saturn up in a few minutes. All right, we're here on the rooftop of Salt. We're just in the process of getting Saturn for everyone to enjoy, and we'll have that up in just a minute. You can see lots of people out lined up at about a dozen telescopes that we have out here, and we're going to head on over and share Saturn right now. All right, so there's Saturn in the middle of our field of view. It doesn't look like much right now because we have a telescope with a wide field of view. Oh, let's hear a few words from one of our hosts.
I hope is everybody having fun? You enjoying the stars? Round of applause if you're enjoying the stars, please. Live off applause. I'm Sam King. I'm the executive director of ʻOhana Kilo Hoku. We are a 501c3 Native Hawaiian nonprofit organization that supports astronomy and space programs in Hawaii and beyond. And our mission is to cultivate in our keiki, all the keiki here, a relationship with the stars and to advance their dreams in pursuing astronomy and space and just enjoying the science of the stars. ʻOhana Kilo Hoku created this entity, this ʻOhana Stargazing event, and our partners with Nick in Stargazing Hawaii and the University of Hawaii's Institute for Astronomy and Kamehameha Schools really took off with this event here at SALT and blasted out. So round of applause for all our partners from the schools. So one of the things about ʻOhana Stargazing is just sharing everybody's knowledge with the stars, showing how it's all equal and all valued. And so, of course, we're here in Hawaii, and the thing for our nonprofit is the Hawaiian relationship with the stars. So we have Kailani Murphy here, who is a navigator with Hupulea, who's going to speak. And she's going to say some words about the navigators and our heritage. It's near and dear to my heart. One of her mentors, one of the captains she knows was Kalepo Babaya. If you don't know, Kalepo was one of the founding members of ʻOhana Kilo Hoku. And so he passed away shortly after our group was formed. And he was really the heart and soul of our group. And our kuleana is to carry on his vision. And his vision is what all of you are doing here tonight. So mahalo nui loa for keeping his spirit alive here. And I will turn it over to Kailani. Mahalo.
Aloha Kakaʻako. How's everybody doing tonight? Nice to hear me. Awesome. Well, I'm really honored and grateful to have been invited to share tonight. I'm stoked to see that there are a lot of people here. As Sam said, my name is Kailani Murphy. I come from Waimea, tiny place on Hawaii Island. And when I came to school here in Beach, I got involved with kids. Fortunate to have some of my first teachers on the bus, Nainoa Thompson, who is he's from Hawaii. He's our first navigator from Hawaii in Kennedy. Yeah, so when navigation is about is about instruments, the way that our people are out here on voyaging journeys. We were really lucky at that time that actually Moku'u's first navigator, Papa Maupia. So I actually brought pictures to show, but it's already dark. It worked better during the night. So I kind of put them at least up against the table back here in case you want to walk around and check it out. Papa Maupia was Moku'u's first navigator on her first voyage in 1976. Many of you may have heard of his name. Nainoa Thompson was one of his students. He made the first voyage, Nainoa's first voyage navigating in 1980. So Hokule'a's first voyage in Papamau was in 1976. And then Nainoa made his first voyage as the lead navigator with Papamau on board as his teacher in 1980. And Hokule'a continues to sail today. Many of you might have heard that she went around the world recently. In 2014, she left Hawaii and went south to kind of retrace some of those earlier voyages and went all the way around until coming back home in 2017. Right over here, nice big welcoming homecoming at Magic Island. If you were there, it was a pretty powerful event. But Kalepa Babayan, who Sam also mentioned, is another one of Papa Mau's students and also a student of Nainoa. And he actually did more of the worldwide voyage than any of our captains and navigators. He did more than half of the voyage. Part of the voyage, I guess some of the rules, I guess, was that some of our top leadership our co-navigators had to be important. So Kalepa was on board to teach many more navigators. So since the very beginning with Papa Mau, and his students continuing to teach this ike that we have to relearn, which was sleeping at the time Hokule'a was born. We have many more of us students of navigation who are learning thanks to these teachers. I always like to point them out. I'm really lucky to have been able to learn with both Nainoa and Kalepa. And others like Bruce Lankenfeld and Chuck Sean, I'm sure you've heard of him. And got to spend some time with Papa too. So I'm really a fortunate student still learning. And what I'm going to try to share tonight is a little bit of what we can see in the sky and how, like, if we were actually on a voyage right now together, maybe what we would be looking for and how we would use what we're seeing to find out. So what I have set up down here on the ground here is our Hawaiian star compass. This is something that Nainoa Thompson developed based on the compass taught to him by Papa Mau. And it is our kind of our foundation for our directions. Right? So when we're out on the ocean, we have no compass or GPS. Yeah, not even, we cannot use our phones to see which way is north or.
So our wide field telescope shows Saturn as this little blob, and you can kind of make out the rings. And what we're going to go ahead and do is change the exposure so that Saturn will be overexposed, will be very bright, but we'll be able to see some of Saturn's moons, including the largest one, Titan. So give us a few seconds and we'll get that set up.
All right.
Okay,
What
so now
direction
that
is
bright overexposed blob that looks like a bright star in the
Alright, very
center
good.
is
Just
Saturn,
past the
and
text
above
already,
and to the
you
right
can
of
start,
Saturn
getting on the
is
moon.
its
So
moon
yes, the
Titan.
express. Hawaiian, we call it ʻOhana. Komo is to enter. Hana is like the act of entering. So the
We're
sun is
adjusting the
entering
image
horizon.
so you can
What's on the opposite
maybe
side
make
of
it out
us?
a little bit better.
East, all right, and east is so we need a compass here. All right,
The
so
two
north is
objects
Akau,
sort of a little bit down and to the right are background stars that we can see
the Hawaiian word Akau is also the word for right.
behind,
So if you're
walking
facing the
distance
sun
behind
and
Saturn.
you bow to the setting sun, Akau is on your right. And what's on this side? What's to your left if you're facing us? South,
Two little
yeah.
dots in the
And
bottom.
so that's a little bit of their challenge.
As you can see, right in the diffraction spike to the left of Saturn is a tiny little blob. That is the moon Rhea. And there's another faint one sort of at 7 o'clock that's coming in and out. That one is Dione.
Beautiful clear sky.
That's all we can see.
You would be able to see an important star that is following the sun down.
There's another one down here that we can't see.
Does anyone know
We can't see
what
it
that
right
is
now.
up there?
Right now, we can't see any of the other moons, but we've got these three. So Dione, Rhea, and
Okay, so
at
do you
Titan
folks-
at about
do you
2
remember the
o'clock.
canoe I
There's
mentioned?
Titan at 2 o'clock.
Yeah, Papa was our first nav- Yeah.
An interesting fact about Titan is that we're about to send a total science fiction-like mission to Titan called Dragonfly, which is basically a giant quadcopter, like a big drone, that will fly over Titan and examine its surface. That mission is about 5 or 8 years down the road, but it's in development right now. So now you're going to see everything blur out as we're going to slew over to the Ring Nebula.
And even without
And it'll take us seconds to maybe a few minutes to get over there. And when we get there, it's quite faint, so it's going to take some time for the telescope to add up deeper and deeper pictures until we can actually see the Ring Nebula. So when you see bright streaks of light flying by on the screen, that's because the telescope is moving. So this nebula, the Ring Nebula, is in the constellation Lyra, or the Lyre. An interesting thing about this constellation is that there's a famous star here, RR Lyra, which is the prototypical type of one kind of variable star. So that's a certain type of star that varies in brightness over time, and one of the best studied ones is in this constellation. But we're not going to look at that because it varies over time scales that we can't observe right now tonight with our telescope. Instead, we're going to head over to the Ring Nebula. Well, the telescope has reached its target, but it's quite faint and the sky here is quite bright. So we're going to have to let it keep adding up pictures over a minute or two until we can see it show up here in the middle. It's called the Ring Nebula because it looks like a ring, like a circle. And this kind of nebula is a planetary nebula. A planetary nebula has nothing to do with planets. People call it that just because in the old days when telescopes could not resolve things very well, they look like blobs that look similar to planets. A nebula just means it's fuzzy. So it's a fuzzy thing that looks kind of like a planet. But in fact, this is the thrown off outer layers of a star like our sun that has died. So hopefully in about 2 or 3 minutes, we'll be able to see it. Oh, here it is. It's coming up in just a minute. I already see it here in our screen. And you should be able to see it in about 10 seconds or so.
Yeah, you can kind of see it.
So you can see the colors. The inside is greener and the outside is red, and that's emission from different kinds of atoms. The green is probably oxygen. The red is probably hydrogen.
Zodiac constellation. What is that? Most important thing.
So this is a planetary nebula known as the Ring Nebula. The end fate of our own sun will be something similar to this. When it first will puff up so big that its outer layers actually envelop the Earth. Our sun will become over 100 times bigger than it is today, which means the outer layers will extend to Earth. And then those outer layers will get blown off and leave a tiny object in the middle called a white dwarf, which will be about the size of the Earth and made basically purely of carbon. It'll be like an extremely hot, very dense charcoal briquette. And the outer layers of the sun will become a beautiful nebula like this, visible to others years from now, billions of years from now.
at sunset.
When we
Alright,
do
so
another
ʻOhana,
event here
as
or
it's getting
another
closer,
ʻOhana
we have
stargazing
another
at a different
directional
location, we're going to be
And
on
then
Maui
these guys
on
are
October
also
15th,
getting lower, and when they set,
and
we
there'll be
also
future
know
ones in
another
about one a
direction.
month
For
across the
example,
islands.
this one,
If you hear
this
noise
is
in the background, we have a
this one,
navigator
the
explaining
reddish
how
one,
Polynesian
that's
navigation
Scorpion,
works using
or
a
Antares,
big
and Lehuapan
star
is
compass that
RE,
they've laid
and it
out
actually
right here on the
sets
parking deck.
200
We have activities
south of
downstairs,
west. So
allowing
we
you to
have
walk through a scale model of the
Hokulea,
solar system, see how
19
gravity
degrees
warps
north of
space,
west,
learn how we
Lehuapan
learn about the universe using
26
light, play with
south
Lego,
of west,
and
then all these other
put on
stars
VR goggles, virtual
the same
reality
thing.
goggles,
We
and
have
imagine being a
together they
navigator out on the
horizons,
ocean.
so when they go down, we have
It's
the
great
direction.
activity, lots of families out here, and plenty of food
That makes sense.
opportunities.
That's pretty simple.
Come bring a picnic
You just
or
have to
enjoy food
remember.
at one of the restaurants and hang out
So
on a beautiful
we're gonna
evening.
shift over.
So it's going to be down.
Is actually
We're going to
right. It
restart
goes
the image
to
here and try to see if we can get a slightly
so
better
it's
image.
right in the
There's
center
hundreds of
between
people
them.
up here on the rooftop
It's
deck with us,
nice to know
and
that
it's actually
directions.
vibrating all the telescopes quite a bit. So we're going to see if we can catch a better glimpse, and we'll hang out here on the Ring Nebula for a little bit,
And I'll just point out some other stars.
and then
and
we'll
give you an
venture
idea
over to explore something else
you
in
get
another
to
10 or
memorize
15 minutes.
So it's moving now.
So there's our last view of the Ring Nebula, and we're slewing our way over to the Dumbbell Nebula.
Looking at all the
So the last nebula we looked at looked like a ring. This one will look like a dumbbell. It's like two reddish circles with blue in the middle. And that's because instead, a planetary nebula is not a sphere. It's more like a cylinder or a pair of cones. And so depending which angle you look at it from, it might look like a circle, or it might look like a helix, which there's one called the Helix Nebula, or it might look like a dumbbell. So when we go over to the dumbbell and it integrates for a little while, we'll be able to see that one, hopefully. Same kind of object, the leftovers of a dead star, similar in mass to our sun, that's blown off its outer layers. And the structure of the material that's blown off is not a sphere because of the magnetic fields that entrap the various ionized gases. So So hopefully we'll see that pretty soon. If you could read quickly and saw what went by on the screen, this was the first planetary nebula discovered. You'll notice that it also says M27. M stands for Messier, which is a French astronomer who made a catalog of fuzzy things, nebula, in the sky. And hence the M is from his name, and he just numbered them. And some of them are galaxies, like the Andromeda Galaxy, which we'll look at later, is M31. This nebula, which is also fuzzy, is M27. There are hundreds of objects in his catalog, and many of them are nearby galaxies, and many others are nebulae or star-forming regions, leftovers of dead stars, and things like that in our own galaxy. And there you can see that fuzzy object is the Dumbbell Nebula, and you can see it looks like a pair of cones placed back to back, and it's redder on the outside and bluer on the inside. You can imagine rotating that towards us, and then you would see a circle much more like the Ring Nebula, which we saw before.
But the idea is, if you know where all of
And you can see it moving around a little bit. That's the truth of all the motion up here on the rooftop.
Some stars, you should know exactly where everybody else
My colleague Mitchell Dennis, who's here next to me helping run the telescope, he's one of our graduate students, tells me this is also called the Apple Core Nebula for obvious reasons. It looks like you've enjoyed an apple and you've got just the core and the stem areas left. I've never heard that name for it before. I've always heard it referred to as a dumbbell. All right, well, we've had enough of the Dumbbell Nebula here, so we're going to slew over to Jupiter. And like Saturn, because this is a wide field telescope, we won't see too much detail in Jupiter, but we'll be able to see a couple of the moons of Jupiter lined up around it. So we're going to head on over there, and we should be there in a minute or two. All right, so that bright object in the middle right there is Jupiter. And you can see 4 of its moons lined up in a nice straight line. Starting from the bottom left at about 7:30 is Callisto, Ganymede, Io, and on the opposite side of Jupiter is Europa. And that pattern of the moons, they orbit quite quickly. So if you were to come back and take a picture of Jupiter tomorrow, you'll see them in a different pattern, and there are websites where you can go look up which is which. but it was actually the observations of these moons of Jupiter, which are called the Galilean moons, because Galileo saw them through his small telescope and observed them moving, that upended the view of the Earth being at the center of the universe. They saw that objects were orbiting something else besides Earth, which meant Earth could no longer be the center of the universe. Before that, it looked like all the stars were moving around Earth. They thought that the planets moved around Earth, although they had to invent ever more complicated kinds of motion called epicycles to explain them. But when Galileo observed the moons going around Jupiter, and it was clear that they were orbiting Jupiter, it meant that not everything in the universe was going around Earth, and that was the end of that model of the universe. So if you look at the planets in our solar system going around the sun, which this kind of looks like, then the plane in which all the planets, except Pluto, which is not really a planet anymore, orbit is called the ecliptic. Not elliptic, but ecliptic. E-C-L-I-P-P-I-C, like eclipse. And so the plane of the ecliptic is the plane that all the planets orbit the sun. Jupiter has its own sort of mini ecliptic, which is the plane in which its moons orbit Jupiter, which is why they're all in a straight line. If you go out at night and a bunch of planets are up, you can see Saturn and Jupiter like you can see tonight, and also see one or two more like Mars or Venus, and you see them making a line. That line that they make is the ecliptic of our solar system. So you're seeing the plane of our solar system at night. So the moon that's just to the lower left of Jupiter is Io, which is incredibly volcanically active because it's being pulled on gravitationally with very strong tidal forces by Jupiter. So it has enormous, very active volcanoes with huge plumes that we can actually see from here on Earth or using telescopes like Hubble Space Telescope. Europa is famous because it's covered in ice, underneath which there are oceans. So it is a place where we can imagine there being life because there's liquid water under the surface of Europa, which is a lot like Antarctica here, where you have a thick layer of ice and water underneath it. We see things that live in that water. So there could be things living in the frigid waters of Europa. And people envision missions that would drill or melt their way through the ice of Europa and drop a little submersible to go exploring.
And so just like
All right, so we're still here on Jupiter. From left to right, bottom left to top right, we're looking at Callisto, Ganymede, Io, and Europa. And that'll come back in a second. And if you go and look at Jupiter with binoculars, small household binoculars, birding binoculars, you don't need anything fancy. You can see these 4 moons with your eyes through binoculars. And if you go look tomorrow, you'll see that they're in a different pattern because these moons whip around Jupiter very fast. Our moon takes 28 days to go around Earth. The inner moons of Jupiter take 11 or 12 hours. So if we were to even stay on here for another hour or two, we'd see them oriented differently than they are now. So the moons of Jupiter orbit very quickly because of Jupiter's very strong gravity. And it was the motion of these moons around Jupiter that convinced people hundreds of years ago that Earth was not the center of the universe. Because up until then, they thought everything orbited Earth. But when Galileo Galilei, the famous astronomer, used a small telescope and observed the motion of these moons, it apparently became immediately clear that these moons were not going around Earth, but were in fact going around Jupiter.
And this huge, massive black.
It's under the moon.
We're going to go take a stab at heading over to the Trifid Nebula, which is actually a mix of different nebulae and an open cluster. If you see that little map on your screen, that teapot is actually Sagittarius, the constellation Sagittarius, the bull.
Maybe they have versions.
There is.
So this nebula is going to be another one of those fainter objects, so it's going to take a little while for us to get there and then for the images to add up enough so that we can see it. But in here you'll have an open cluster, which is a cluster of stars that all form together and are now sort of spreading apart. The Pleiades is a famous example of an open cluster. Plus there's a reflection nebula, which means it's light reflecting from bright hot stars, as well as sometimes a dark nebula where there's so much gas and dust that you can't see through it, so it looks like a dark patch against a bright background. So as you see the telescope moving around, trying to find its way, or it's an automated telescope, so once it orients itself. Well, we've arrived at the Trifid Nebula location, so we're going to see if the telescope can image long enough on our shaky platform here on the top deck for us to be able to see it. And in a few minutes, I'm going to hand over the reins to my colleague, Mitchell Dennis, who's one of our graduate students, to provide the narration, because I'm going to be doing some live Q&A right here on the rooftop for our audience here. Okay, so the image of the Trifid should be coming up here in a moment. It'll be up in the sort of bottom right of our screen in just a few seconds. The live stream is a little bit delayed from what we're seeing here in the telescope. There it is. And so you can see in the sort of bottom right corner of the screen that nebula, that bright glow, but you can also see a dark streak through it where there's so much material that the light is unable to make it through. That's gas and dust. That's actually dust similar to what ends up in the corners of your house or apartment or dorm room. You can see a little open cluster of stars, and then the different colors. You can see a little bit of red, a little bit of green glow, all from the emission of different gases that are illuminated by the stars. So this nebula is a star-forming region, so it's a place where stars are being born. You might have seen the recent image from the James Webb Space Telescope called the Waterfall, which is also a portion of a different star-forming region, a tiny portion of a star-forming region like this. And so deep inside those dark regions, stars are in their cocoons, and the young hot stars are illuminating the gas. And there's a lot of small, you can see a lot of faint stars around here because there are stars that have been born from the nebula in this region that have already sort of made their way out of their birthplace and will eventually be pulled apart and spread out over the galaxy. This nebula is only about 300,000 years old. It's about 20 light years across, so the distance to get from one side to the other of that bright spot would take 20 years for light to travel from one side to the other, which is actually quite small and astronomical.
It's 9,000.
And it's 9,000 light years away from us. If you have a small telescope at home in a dark location, you'd be able to observe this. It's a quite bright nebula, not visible to the naked eye or small binoculars. And now as it's adding up, you can really see a distinct color. You can see the reddish region in the bottom right with the dust lanes to it, and then you can see a fainter green blob above and to the right of it, which is oxygen emission. The red is from hydrogen. H2 we call, which is hydrogen atoms with one electron stripped off it, which actually means it's just a proton, just a hydrogen nucleus. So my colleague Mitchell is going to take over narrating and sending you to other objects. But we'll hang out here for a bit because this is a beautiful object. Here's some other space facts.
So the question was,
So, ladies and gentlemen, we're going to slew our telescope now. There are several interesting nebulae up in the sky right now. We're going to try to move towards the Eagle Nebula. For those of you who know what the Eagle Nebula is, don't spoil it for anyone else. But it's another one of these sort of star nurseries, and it's got a very famous feature in it. So we're going to slew, and we're hopefully going to catch a really good picture of the Eagle Nebula. So let's get it, just keep watching. We're going to notice the telescope start slewing, and then we'll move over to the Eagle Nebula. So for those of you watching, you may have noticed these pauses. There are several pauses that happen at regular intervals. That's because every time the telescope is moving, what's happening is it's figuring out its location, and then it moves again, and it figures out where it's gone to. That's because it's really difficult to get precise positioning when you do small micro adjustments like this. It's actually much easier to just figure out our position on the sky, make adjustments from there, as opposed to having the computer know perfectly where we are based on the motor position. So it coordinates its position based on what it sees, not necessarily on how far it's gone. It uses the GPS location that we're at, and it also uses the stars that it's looking at to get a more precise location. It looks like we've settled on the Eagle Nebula. I'm going to start what's called enhancing the image. You may notice there's a distortion in the center of this star cluster here. That is actually where we will look for this nebula. All right, gang, it looks like we've found the Eagle Nebula. For those of you who have got a clearer picture, you can see it's sharpening up. I'm going to zoom in so that we can see the pillars of creation. I've zoomed in. It'll take a while to appear on your screen, and we'll give it another moment to reduce the blur. The Pillars of Creation are another one of these stellar nursery groups. They're very, very famous because they're these 3 tall pillars of gas clouds that we see. The image on your Zoom feed is it's a little blurry. Give it a moment to clean up. But you can kind of see the pillars that we're looking at. They're going to be right in here. So there's one of them. And we got more in here, 2 more in here, and then there's more things happening down here. And these are interesting because they're essentially a stellar nursery, just like what we looked at, but they're very, very distinct within this nebula and indeed within this cluster.
Scale model of the solar system set up, and in that model, the sun is the size.
So this nebula is, once again, it's an H2 region like the previous object we were looking at. That means hydrogen is being ionized or excited, so the stars are heating up the gas surrounding them as they're born, and they're exciting hydrogen. So that's why we call it an H2 region. It's about 5,700 light years away, and it has a cluster that's associated with it. So it's not only a nebula, but it's also an open star cluster. You see a bunch of stars in this region. The open star cluster has something like 8,000 stars, and it's very, very bright. So it's easily seen on our sky. It was also cataloged by the astronomer Messier. It's Messier 16. So I'm going to zoom out a little bit, but I'm going to leave us on this object because I think it's particularly beautiful. For those of you who are at home watching this, feel free to Google pictures. You can look at different wavelengths of light. We're working in visible light right now, but a lot of exciting stuff happens in what's the infrared light. This is things that basically it's describing what we would think of as heat. And so I would encourage you all to look at composite images that are visible light and infrared light. You can do that just by Googling the Eagle Nebula on Google Images, and you can find some really, really incredible pictures on on the internet of this nebula. All right.
Or look, which ones can we look?
For physics.
All right.
He was
So
asking if-
we're gonna move
Oh,
on
if
from
the
the
Earth
Eagle
is
Nebula.
like-
We're going to
I mean, the moon is
try to
probably
find a
lots of
galaxy if
Earth
we
and
can, but I don't think anything is quite high enough in the sky for Honolulu. But if not, we're going to look at another nebula or another star cluster. So give me a moment. I'm going to figure out what we're going to look at next, and then we'll slew the telescope. So it looks like NGC 6946 is up, and it's pretty high in the sky. It's kind of faint, but we're going to do our best to see if we can't spot it. So give us a moment for it to appear on your screen. We're going to slew to that target. It sits about 51 degrees off the horizon in the north direction, and it sits in the Cepheus constellation. You'll see that come up on your screen as well. So we're going to point there, and we're going to hope that we get a nice view of this galaxy. It's also known as the fireworks galaxy because there's some exciting stuff happening in the infrared, particularly lots of star forming. So it looks like our target has been validated. Give that a moment to appear on your screen, and we are going to begin to enhance our image. I'm optimistic. Hopefully we'll be able to see at least parts of the regions of dust on this galaxy. It looks like we may not be able to get a solid view of this galaxy. I'm going to give it a couple more minutes to see if we can clean up this image, but I'll keep you posted. So give it a moment, folks, we're gonna look towards the left side of our screen. The left half of our screen is where this is gonna appear. You can see a slightly grayish region appearing with a slightly dim center. That's the target we're looking at. And as the telescope integrates, we're gonna be able to see more of the spiral arms. One thing astronomers note about this particular feature is it's beautifully symmetric when we view it in multiple wavelengths. All right, gang, notice we have the arms actually appearing on sky. I'm actually going to draw them quickly for you so you can see them. So if we look on sky right here, here's one of the arms and here's another one of the arms. And there's another arm kind of extending out this way and another arm extending out this way. So these arms are here on sky and we can see them because they emit light in the visible spectrum. But in the infrared, there are a lot more interesting things that we can actually see. Now, I'm going to go ahead and clear off these drawings so that way you can see the arms for yourself. This galaxy is notable because there's a lot of star forming happening inside these regions. And so we look to these galaxies to kind of understand how stars form in galaxies and how those regions then interact with the galaxy as a whole. All right, I'm going to give us a few more minutes on this galaxy because I think it's one of the prettier ones that's up right now, and then we'll try to find a new target for us to look at. All right, guys. You can see the regions of our galaxy here really quite well, and you can see these little bright spots. I'm gonna draw them on here. These bright spots right here are our star forming regions. You can see the arms coming in quite nicely, but I'm going to move our telescope view to another nebula. I hope you enjoy nebula. I think nebula are some of the really pretty objects that we can see, and I'm going to move us to one called the Helix Nebula. So for those of you who've seen this nebula before, you'll get to see a nice picture of it again, and for those of you who've never seen it before, well, you'll get to see something new. So I'm going to stop our view of this galaxy. Again, it's the Fireworks Galaxy. I would encourage you to look up some of the really incredible pictures taken of this galaxy recently. I believe James Webb is either about to take pictures of this galaxy or they already have released images of this galaxy. So I would encourage you to look at James Webb images of all of the targets that we've observed tonight, if they are available. Some of them may not be available quite yet. I'm going to start the slew, and I'll be back as soon as the telescope is done slewing. All right, folks, if you look in the right-hand side of our screen, we can actually see the Helix Nebula. It's kind of two little circles. I'm going to draw them for you now. So if I draw these circles, we can see there's one right here. And there's kind of a second one that comes out around here. So you can see these circles. This is also a very diffuse system. It's very dim, kind of hard to see with our scope. So it's taking a little bit longer to come online. This nebula is particularly interesting because it is also a planetary nebula. These circle outlines actually can look like an eye when they're viewed in a different wavelength, and so they're really quite something special when you see them in all of the wavelengths. So I would encourage you to look at them. It's located in the Aquarius constellation, and it's only about 650 light years away. I'm going to go ahead and clear these off so you all can see where the rings are. So this is a planetary nebula, as we were looking at earlier, which means it is a star that has exploded. It's also been nicknamed the Eye of God because it can form a very bright eye if you have a very long exposure. So from our vantage point, it looks like it's got a helix structure, which is why it's called the Helix Nebula, and it's destined to be visible as a white dwarf eventually. This is a star that has shed its outer layers in the red giant branch phase, and its destiny is to become a red dwarf. We can see the pictures coming in a little clearer, so I'm going to give us a few more minutes just to get a really nice, clear image of this before we move on. We're running up towards the end of our event, but I think we have time for perhaps one more target before we say goodnight for now, and hopefully you'll join us again soon. We'll be doing more stargazing events throughout the islands as the year progresses. So we've been on this target for a little bit now, and we can actually kind of see the eye-like structure right here. So we kind of look right here. We can see this almost eye-like structure forming if these were the two lids that I've just drawn. So that's why it's sometimes known as like the God's Eye Nebula. But I think it's a particularly pretty image. You can see the lighter colors on the edge, like the redder colors on the edge, and then there's bluer colors as you go inward. These are again in the order of elements typically, so that the edges are going to be stuff like hydrogen. The bluer stuff is going to be things like oxygen. We are going to change our target in a couple minutes, but I'm going to leave this one up for about 60 seconds to a minute or to 2 minutes longer, just so you guys get a nice clear picture of the Helix Nebula. All right, we're gonna look at the only galaxy we can see with the naked eye on a clear night. It's also called the Andromeda Galaxy, and we're gonna start slewing now. So we're gonna take a moment and slew to Andromeda. Hopefully we'll get a nice clear picture of Andromeda. Some of you may have noticed it still says it's slewing, but we can obviously see Andromeda. It's just coordinating the stars right now, and it's validating its position on the sky. So we just got our position validated. You'll notice Andromeda's looking kind of hazy. That's because this is a turbulent system we got going on here. There's also some light pollution. We're gonna, once again, enhance our image, although notice we don't have to do that for this one, as opposed to some of our nebulae. But we're gonna enhance our image and hopefully we'll get a crisper view of the Andromeda Galaxy. So this is the Andromeda Galaxy. It is one of the brightest objects on the night sky. It's among the brightest of the Messier objects. It's known as M31, and it's actually on a collision course with our own galaxy. So the Andromeda Galaxy is 4 to 5 billion light years from us, meaning that's how long it takes light to reach us. And it is on a collision course. It will eventually get to us. However, while it's a collision course, that's kind of a misnomer because it actually won't collide with us. We will interact gravitationally, but the likelihood of any individual object in the Andromeda Galaxy impacting any individual object within the Milky Way galaxy is fairly small. And also, I misspoke earlier, the collision will happen in 4 to 5 billion years. The distance to this galaxy is 752 kiloparsecs. So this galaxy will collide with Earth, or with Milky Way galaxy, and eventually will form, after all the gravitational perturbations settle down, will form an elliptical galaxy from the two spiral galaxies. There's also a chance that one of its neighboring dwarf galaxies could get tugged along with it and interact with us as well. That remains to be seen, but this galaxy is one of the few that is actually headed towards us, so its light is blue shifted instead of red shifted, which means that the wavelength of the light is changing because it's either coming towards us or going away from us, kind of like how the pitch from an ambulance changes as it drives past your house. It'll have one pitch coming towards you, and that pitch will change, and then it'll sound different once it's gone past you and it's heading away. The same thing happens with light as it travels through the universe. So that's all we have for you all tonight. Thank you for joining us on our live stream. We're hoping to do more live streams in the future in and around Oahu and some of the other islands. We'll be doing more events like this, and we're trying to bring them out away from Honolulu to other areas where there's a little less light pollution, and so we can reach different groups of people. So keep an eye out. Look for us as we make our stops around the islands, and we hope to see you at one of our events soon.